Good morning, students. This is Arun. Today we are going to see circular singly linked list and double doubly circular linked list. So first, in the last class we have seen the singly linked list and doubly linked list. Now we are going to see circular singly linked list. In a circular singly linked list, the last node of the list contains a pointer to the first node of the list. We have circular singly list as well as a circular doubly linked list. That is what I have said. So we will see here. This is a data part. This is the next part, that is which points the address of this node. So similarly, this will point the address of this node. So see here it will be null. This will be pointed to the first node. This is what circular singly linked list. But in a singly linked list, normal singly linked list, we don't have this pointer which points the address of the first node. So that is what the circular singly linked list. So we traverse a circular singly linked list until we reach the same node where we started. So where we started here we started, that is what they are saying. So it will point the first node, the last node will point the first node. So for example, here this address is 100, 200 and 300. So this node will have the address of this node. This address will be having this node. This address will be contained in this node. So similarly, here the last node will point the first node. So that is what circular singly linked list. So circular linked lists are most used in task maintenance in operating systems. Though the main use of the circular singly linked list is for the task maintenance in the operating systems. You know what is an operating system? That is Windows, Mac OS, Android. So for that purpose, there is a task maintenance. For task maintenance, circular singly linked list is used. There are many examples where circular linked lists are being used in computer science, including browser surfing, where a record of pages visiting in the past by the user is maintained in the form of circular linked list and can be accessed again on clicking them to the previous button. So this is a very good example. That is, in browser you are using the arrow mark button by clicking back buttons, so front buttons. So that is the example for circular singly linked list. Now we will see the memory representation of circular linked list. So in the following image, memory representation of a circular linked list containing a marks of a students in 4 subjects. So however, the image shows a glimpse of how the circular list is being stored in the memory. The start or the head of the list is pointing to the element with the index 1 and containing 13 marks in the data part and 4 in the next part, which means that is linked with the node that is being stored at the 4th index of the list. Now we will see the example. See here, this is the start node. So 13, data is 13 and the next address is 14. Data is 13 and the next is 4. So where is 4? So here. Where is 6? Here. And where is 8? Here. See here, the last node points the address of the first node. This is what? Circular linked list. So see here. So 1 is the address. So 13 is the data. 4 is contain the address of the next node. So at the 4, 15 is the data and 6 contains the address of the next node. At 6, what is the data? 19. 8 contains the address of the next node, so 57. And see here, this one is the address of the first node. This is what circular linked list. Now we will see the operations on circular linked list. What are the operations? One, insertion at the beginning, insertion at the end. Adding a node into a circular singly linked list at the beginning. We are going to add a node in the beginning. That you call it as insertion at the beginning. Next, insertion at the end. Adding a node into the circular singly linked list at the end. So we are going to add a node at the end. Now we will see the deletion and traversing, how we can delete the node and how we will traversing. So deleting at the beginning, that means removing the node from a circular singly linked list at the beginning. We are going to remove the node at the beginning. That you call it as removing the node from the circular singly linked list at the beginning. Next one is deletion at the end. Removing the node from the circular singly linked list at the end. Next one is searching. Compare each element of the node with the given item and return the location at which the item is present in the list, otherwise return null. So it will search the element. If that element is present or the address or node are present, it will show you the address or the data present in that node. If not, it will return null. Traversing, we see each node of the list at least once in the order to perform some specific operation. So this is what circular linked list. Circular linked list means the last node will contain the address of the first node. So here, from here it goes and points this node. So that is what circular linked list. Now we will see the circular doubly linked list. So I have already said circular doubly linked list already we have seen. So it points in both the direction. So this is the head, this is the first node, this is the data present here, this is the address present here. So we will see that. So what is first? We will see the doubly linked list introduction. Circular doubly linked list is more complex the type of data structure in which a node contains pointers to its previous node. That is, a node contains a pointer to its previous node as well as the next node. So that is what here I have said. So see here, this is the pointer of this node and this is the address of this node. So it contains both the part. So we will see with the example. Circular doubly linked list doesn't contain null if any of the node. The last node of the list contains the address of the first node of the list. The first node of the list also contains the address of the last node in the previous pointer. This is the difference between the circular singly linked list and circular doubly linked list. So see here, it will not point the null because it will contain the address of the first node will contain the address of the last node and the last node will contain the address of the first node. That is why see here both the ways. So it is two way, both the ways arrow mark is present here, but in the singular linked list only the arrow mark will be pointing to the first node, not to the last node. Due to the fact that a circular doubly linked list contains three parts in a structure, therefore it demands more space per node and more expensive basic operations. However, a circular doubly linked list provides easy manipulation of pointers, and the searching becomes twice as efficient because it points the both the address. It contains the address of the neighboring node. So see here, we will see the memory management. See here, data, previous node, next node. So this is the first node in the doubly linked list. See here in the last node, so it is the data, previous node is 6. So this is the first node, data is A, previous node is 8. See here, doubly linked list, it points the address of the last node, and the next will be 4. So it points, data will be B, previous address will be 1 and 6. Next node will be 6. So data will be C. What will be the previous address? 4. Next address will be 8. Now D. So D is the data. Previous address is 6. The next address will be 1. So this first node contains the address of which node? Last node, and last node contains the address of, see here, 1. 1 is the address of the first node. This is the memory representation of the circular doubly linked list. See here, the following figure shows the way in which the memory is allocated for a circular doubly linked list. The variable head contains the address of the first element of the list, 1, that is 1. Hence the starting node of the list contains the data A is stored at address 1. Since each node of the list is supposed to have 3 parts, that is the data, previous part and the next part. Therefore the starting node of the list contains the address of the last node 8. So see here, last node 8, this is the last node, this is the address. So last node 8, and the last node contains the address of the first node 1. And the first node is the image 1. In the circular doubly linked list, the last node is identified by the address of the first node, which is stored in the next part of the last node. Therefore, the node which contains the address of the first node is actually the last node of the list. So the first node will contain the address of the last node, and the last node will contain the address of the first node. That is the circular doubly linked list. So we will see the operations. Inserting at the beginning, adding a node in circular doubly linked at the list at the beginning. Insertion at the end, adding a node in circular doubly linked list at the end. Now deletion at beginning, removing a node in circular doubly linked list from beginning. Deletion at end, removing a node in a circular doubly linked list at the end. So these are the operations we are performing in the doubly linked list. So in the next class we will see the programs for circular linked list, circular doubly linked list, singly linked list and doubly linked list. Thank you.